Hello, everyone. Let's start today with a simple thought. Imagine you're in a pharmacy looking at medicine bottles. Some names are easy, like chloroform, while others sound complex, like trichloromethane. Have you ever wondered why the same compound sometimes has two different names? That's exactly what we are learning today, the nomenclature of alkyl halides. Halolcanes are named by identifying the parent hydrocarbon and then adding the prefix for the halogen. In common names, we simply use the alkyl group name followed by the halide. For instance, CH3CH2Cl is called ethyl chloride. In EUPAC, however, the same compound is called chlorothane. For benzene with a single halogen, the story is simple. Common and EUPAC names are identical. But as soon as we get multiple substitutions, we need systematic rules to avoid confusion. That's why EUPAC naming is so powerful. It ensures clarity no matter how complex the molecule looks.
Now, let's compare the common system and the IUPAC system. Common names are based on tradition. For example, we say tert-butyl bromide or sec-butyl chloride. But in IUPAC, the same compound is renamed systematically with numbers for the locants. Take sec-butyl chloride. Its proper IUPAC name is 2-chlorobutane. Or look at tert-butyl bromide, which becomes 2-bromo-2-methylpropane in IUPAC. Similarly, neopentyl bromide is renamed as 1-bromo-2,2-dimethylpropane. Notice how common prefixes like iso, sec, tert, or neo are avoided in IUPAC. That's because the IUPAC system replaces them with precise numbering of carbons. Remember this for exams. Often you'll be asked to convert from common to IUPAC names. Let's now discuss dihalogen compounds, which have two halogen atoms. These can be of two types, geminal and vicinal. In geminal dihalides, both halogen atoms are bonded to the same carbon atom. For example, methylene chloride, CH2Cl2, is also called dichloromethane in IUPAC. In vicinal dihalides, the two halogens are on adjacent carbons. For example, CH2Cl-CH2Cl is called ethylene dichloride in common system and 1,2-dichloroethane in IUPAC. So, geminal means same carbon and vicinal means neighboring carbons. Don't mix them up. It's a common mistake in exams. Let's look at some important examples you'll find in the textbook. Take CH3, CH2, CHCl, CH3. Its common name is sec-butyl chloride, but in IUPAC it is called 2-chlorobutane. Now look at vinyl chloride, written as CH2 double bond CHKl. Its IUPAC name is chloroethene. Allyl bromide, written as CH2 double bond CH-CH2Br, becomes 3-bromopropene in IUPAC. Chloroform CHKl3 is actually trichloromethane. And carbon tetrachloride CCl4 is renamed tetrachloromethane. These examples from Table 6.1 show how common everyday names like chloroform and vinyl chloride fit into a systematic IUPAC framework. Let's dive into the world of isomers with C5H11Br, which has 8 possible isomers. Ready? Let's break it down. Step 1. We begin by drawing all possible chain and branch structures. Look at the figure. Can you spot the different ways the carbon chain can be arranged? Step 2. Now, place the Br atom at primary, secondary, or tertiary carbons. As you see in the figure, Br can be attached to different positions on the chain, each creating a unique structure. Step 3. Using the lowest locant rule, we assign the IUPAC names. The figure clearly shows how the names follow the rule: 1-bromopentane, 2-bromopentane, and 2-bromo-2-methylpropane. Step 4. Finally, classify the bromides as primary, secondary, or tertiary based on where bar is attached. Again, the figure helps guide us. Each structure's classification is visually shown for clarity. Now let's move to aromatic halides. Monohalogen benzene derivatives are easy. Chlorobenzene is the name in both common and IUPAC systems. But when we have two halogens or a halogen plus another group, the difference becomes clear. In common system, we use O for ortho, M for meta, and P for para. For instance, O-chlorotoluene. In IUPAC, the same compound is written as 1-chloro-2-methylbenzene. For dihalogen derivatives, instead of ortho, meta, and para, IUPAC always uses numbers like 1,2, 1,3, and 1,4. Benzyl halates are named as chlorophenylmethane or benzyl chloride, depending on the system. A simple trick, always number the ring substituents in such a way that the sum of locants is the lowest possible. This avoids ambiguity. So, let's summarize what we learned today. Common names are based on alkyl radical plus halide, like ethyl chloride. IUPAC names treat them as halo-substituted hydrocarbons, like chloroethane. Dihalogen derivatives are either geminal or vicinal, and in IUPAC both are named as dihaloalkanes. We also looked at textbook examples like chloroform, vinyl chloride, and carbon tetrachloride, all of which have systematic IUPAC names. We practiced with the 8 isomers of C5H11Br, learning how to systematically name and classify them. Finally, we saw how aromatic halides use ortho, meta, para in common naming, but numerical locants in IUPAC. So the big takeaway is this. While common names are convenient, IUPAC rules are universal, precise, and exam critical. I hope this discussion has made the naming of haloalkanes less intimidating and more logical. In our next class, we'll explore the nature of the carbon-halogen bond and its fascinating properties. Until then, keep practicing and remember, chemistry is not just names and formulas, it's the language of molecules that shape our lives.